one more slide on monochromators. We have something else that we worry about with monochromators and spectrophotometers in general is stray light. So if we have light that makes it through the monochromator that's not at the wavelength we want, it won't be affected in the same way by the sample, and it will lead to errors in our measurements. And so stray light is an issue. It's always going to be present to some amount, but we would like to limit it as much as possible. And so the way this is usually quoted is as a percent of P naught being the amount of light we get when a blank is present or when there's no sample present. So what percent of that reaches the detector. And the way that this affects absorbance is particularly drastic for larger absorbance values. So the higher the absorbance we're trying to measure, the more stray light matters, because more of our light is getting absorbed, and it leads to pretty significant errors in absorbance if we have some significant amount of stray light. I will post a separate sample calculation involving stray light and how we can actually calculate how much the error will be, given a specific amount of stray light. And again, you'll have homework questions related to this, or I think one homework question related to this. Now, where does this stray light come from? One possibility is that you can have stray light from other grading orders, right? So if the wavelength you want to select, you use n equals 2. Well, maybe at n equals 4 for some other wavelength will also make it through your monochromator in that case. So you can end up with stray light that way. You can also get, if you're depending on the design of your spectrometer or whether there's dust on things, you can get scattered light from walls or optical components that can make it through the monochromator on accident. Or it can even come from outside the instrument if you don't have your instrument sealed well. And this is why whenever you use the spectrophotometer, you've probably already seen, we always seal everything up. We have a door that we open and close. We want to get as little light coming from the outside world as possible inside of our spectrophotometer because of this issue of stray light. Now, some ways we can try and eliminate or at least reduce stray light. One is to use an optical filter. So if we have a piece of glass that only lets specific colors of light through, even if something makes it through in, say, a different grading order, it won't make it through the filter. And so if you know you're measuring something within a specific narrow range of wavelengths, you can use this filter, or you can even automatically have this placed and removed for specific wavelengths, with a mechanical arm in your spectrometer. Another strategy, if you're really need really low stray light, if you're doing lots of very high absorbance measurements, is to have a second monochromator. So the first one we'll select, you might get a little bit through, but if you use a second monochromator with slightly different diffraction grading and whatnot, it won't make it through that one. And so this is a more expensive, filters are pretty cheap. It's just a colored piece of glass essentially. Second monochromator involves, a whole other monochromator setup. And so that's a little bit more of expensive way to get around this problem. But that's it for this part on monochromators. In the next video, we will talk about detectors.